Welcome to module 2, which is forecasting part 7 from the production and service system planning part 1. So in a part 6, we have discussed the simple exponential smoothing method. So in this part, we are going to talk about the adjusted exponential smoothing method. So till now we have discussed naive forecasting method, we have discussed simple moving average method, we have discussed weighted moving average method, as well as we have discussed simple exponential smoothing method. All four methods are good methods for if we have only the level component pattern in our data set. So now we are going to talk about if we have the level plus the trend component in our data. The trend could be a linear increasing trend or a linear decreasing trend. Okay. So remember that the trend we are talk about that should be the linear. Okay. If we have a linear increasing or linear decreasing trend, then for that case we can apply the adjusted exponential smoothing method, which is also known as Holt's linear trend method, or you can call it as double exponential smoothing method. Okay, so why we call it as double exponential smoothing? Because in a simple exponential smoothing we were only have a simple or a single smoothing factor or the weighting factor. In adjusted exponential smoothing or a double, we would having the two smoothing factor. One is alpha and another is beta. So the alpha component is going to deal with the level component weightage, whereas the beta component is going to deal with the trend factors to find out the trend factors weights. Okay. So the formula for the double exponential smoothing or the adjusted exponential smoothing method is going to be this one, which is AFT adjusted forecast for the time period t plus 1 is equal to FT plus 1. So this FT plus 1 is nothing but the simple exponential smoothing formula, whereas t plus 1 is basically the trend component formula, and the trend component formula is going to be equal to this one, which is saying that the next time period trend component would be equal to the beta, which is a smoothing constant for the trend. So into ft plus 1, that is this simple exponential smoothing methods forecasting value for the next time period. So this is the tth time period forecast value with respect to the simple exponential smoothing method. So then we have 1 minus beta and t plus 1, which means the last time period trend component value. Whereas once again, because beta is also a weighting factor, so the weight should be between 0 and 1, right? Like the alpha, we always have 0 and 1. So now the question is how we are going to take the value of alpha and beta. As we have seen in the simple exponential smoothing method, if we are manually solving it, so we can use the alpha between 0 and 1 on the basis of the judgment, or you can say on the basis of the trend pattern. That is basically if we have you can say the smoothing data pattern, there is not so much variation in the data, we can use smaller the alpha, which means near to the zeros alpha. But if your data having so much fluctuation, so much variation, we can use the larger the alpha value, right? So same is the case in a beta, we can also use the value subjectively. Okay, so the high beta reflects the trend changes more than a low beta, right? So that means if we having the higher beta, that means the trend changes more compared to if we are using the low beta values, right? Now the question is using this adjusted exponential smoothing method, how we can find out the values. So once again, so this is basically the ft plus 1 column, that is we are going to use by applying the simple exponential smoothing method. So in order to calculate the forecasting using simple exponential smoothing method, so once again we are going to skip this first value. So how we are going to use the initial values, because we need the initial values for forecasting exponential smoothing as well as a trend. So the initial values we are going to compute using the naive approach, that is the February's forecasting value is going to be 36, which is the last time period, which is the January's actual demand. Okay, as well as in order to find out the trend, the initial value we have to assume, because in this formula we have ft. So once again, so we are going to find out the initial value of this trend component. So once again, we are going to skip the first month because we do not have the forecast value over here. So against this, we are going to calculate the forecast, the initial value of the trend component. So the one way we can use is we can use simply these 2 months, and we can calculate the trend value with the help of this second value minus the first value. So 42 minus 36 is going to be 6. But you can also apply this initial value is by taking the average of this one. That is also fine, people do use that one. But what I recommend, either you can use the second value minus the first value, or either you can pick any random number. Okay, but the better one is this one. But right now for this case, I am using the initial value is 8. Okay, so just randomly, subjectively basis, I am picking this number, right? So once we have the initial forecast, we have the initial trend. Now we can find out the forecast ft plus 1, which means next month's forecasted values with the help of simple exponential smoothing, and the trend component with the help of the trend component formula. So we know that how to find out this simple exponential smoothing value. So we know that the value is ft plus 1 is equal to, by using the simple exponential smoothing formula, which is at plus 1 minus alpha ft. Okay, so that means we are going to find out the value of the March, which is the third month. So the alpha value is zero point 0.3 we are using right now in this case, into, so that is the second month actual value, which is 42, plus 1 minus alpha is going to be zero point 0.7 multiplied by the forecast value for the February is 36. So if we are going to solve this one, we would be able to get 38. Okay, so this is 38 we will get. Now, similarly, we can find out the value of April, May, and so on, right? Now, in order to calculate the trend, so what's the formula of the trend? That is the beta. So that means in order to find out the trend component for the month of March, so the beta value is equal to zero point 0.3. Okay, and the formula is f plus 1, which means, so this particular time period forecast, the f plus 1 is, that is a March, which is 38. Okay, and the value is minus the last month forecast, which was 36. Okay, so this is this month forecast, and this is the last month forecast. Then we are going to use 1 plus beta, which is equal to 1, sorry, 1 minus beta is going to be 0 0.7 multiplied by last time period trend component, which is 8. Okay, if we solve this one, we will be able to get the 6. Okay, so this is going to be 6. So same is the case, we can find out the value of April, May, and so on. Okay. So once I have calculated the values of ft plus 1 column as well as t plus 1 column, then I can easily calculate the adjusted exponential smoothing formula, which is f plus 1 plus t plus 1. So that means this value plus this value is going to be the adjusted exponential smoothing formula. Same is the case in order to calculate this one. So this value plus this value is going to be adjusted exponential smoothing. This one plus this one is going to be this one. Okay. So we can easily calculate those values, right? So now the question is that how we are going to find out or apply this method using the Excel. Okay, so let me go to the Excel. So right now I am using alpha and beta is equal to zero point 0.3. As I mentioned earlier, for the simple exponential smoothing, we are applying the naive approach to get the first value, and the trend component, either you can use the second value minus the first value. Okay, or either you can pick randomly any number. So right now I am using 8, but the better way is always you can apply the second value minus the first value. So that is the more appropriate way, but right now I am using 8. Okay, so in order to apply the simple exponential smoothing, what we are going to do is equal the alpha plus last time period actual demand, which was 42, plus 1 minus alpha, which is zero point 0.7, multiplied by the we have the actual forecasted value of the last period, which is the 36. So we are going to get 38. So once we have applied this formula, so we can drag and drop, okay, up to one period ahead. Okay, and then we are going to apply the trend component formula. So what was the trend component? Equal to beta multiply by the this current period forecast, which is E8. Okay, that is basically 38. Okay, and minus last time period forecast, which is 36, plus 1 minus zero point 0.3, which is zero point 0.7, multiplied by the last time period trend component, which is 8 in this case. Okay, so if we drag and drop up to one period ahead, so we are going to get this value as well. Okay, so in order to calculate 2028 value, forecasted value, what are we are going to do is, so we are going to simply adding these two numbers. Okay, so if I am make it in a fractional perspective, okay, so you can see that, so if we are going to add, so the next number is going to be appear, right? So this is going to be this one, right? So we are going to get that is going to be 102, right? So round off into the next number. We have done this one. Okay, now in order to calculate the errors, so what we are going to do is, so that is the actual value minus the forecasted value. Okay, so once we have applied this formula, so we can easily calculate the errors. Same is the case in order to calculate the absolute error, we can apply the absolute of these errors. So that means it is going to be absolute error. So why we are calculating the absolute error? Because the average of these numbers is going to be our mean absolute deviation, or which is also known as mean absolute error. Same is the case, we are going to calculate the error square. So every error square we are going to take. So once we have taken the error square, so the average of these error square is going to be mean square error, right? Same is the case, we are going to find out the absolute percentage error. That is going to be the absolute error divided by the actual value. Okay, so absolute error divided by the actual value. So we are going to consider them or taking them in terms of the percentages, right? So once we have taken them in the percentages, okay, so drag and drop. So the average of these absolute percentage errors is going to be mean absolute percentage error. Okay, so I hope you got the idea how we are going to implement adjusted exponential smoothing method using Excel. Now the question is, as we were taking these values of alpha and beta randomly, okay, let's uh, say that if I would like to optimally find these values, so how we can do that? Okay, let me first of all copy and paste these formulas over here and then remove these values. Okay, now we would like to find out such alpha and beta that this mean square error should be as minimum as possible. So for that we know that we can apply the nonlinear programming model. So what was the nonlinear programming model? Our objective is going to be minimizing the mean square error. Okay, so it's up to you whether you would like to minimize the mean square error, mean absolute deviation, root mean square error, or mean absolute percentage error. And the constraints are the alpha should be less than or equal to 1, beta should be less than or equal to 1, and the both should be positive. Okay, so how we can do that? So we are going to go to the solver, data solver. Okay, so let me reset again, reset it, and we are saying what is the objective. So we would like to set the objective minimizing mean square error, error. So mean square error should be minimized. So the decision variables are alpha, then comma, we are going to another decision variable is the beta. Okay, and we are going to set the constraint that this alpha should be less than or equal to 1. Okay, and the second constraint is this beta should be less than or equal to 1. Okay, so we have these two constraints. Once again, make unconstrained and from the method nonlinear and solve it. So we would be able to get the optimum alpha as well as the optimum beta where the mean square error is minimum. So as you can see that while we were selecting the alpha and beta subjectively, the mean square error was 148. When we are calculating optimally, so we are getting a very small mean square error compared to this one. Okay, so that means optimally finding the values of alpha and beta is more appropriate for us, right? So that is the better one as well. So I hope you got the idea how we are going to apply the adjusted exponential smoothing method on any time series data manually as well as Excel as well as using the Excel solver how we can optimally find out the value of alpha and beta. So thank you so much. See you in the next video.